Nothing bad happened though. Okay. A new social media site is increasing its user base by approximately 5% per month. Okay, I'm going to underline the things that are important. Increasing 5%. If the site currently has 36,100 users, what will the approximate user base be 8 months from now? Okay, so we are going to do three things. We're going to make an equation, a table, and a graph. So this is basically completing the exponential web. First thing I'm going to do is make an equation. And then I'm going to start entering values in the table. Because it's increasing 5%, I'm going to go down here and I'm going to say 100% plus 5% is 105%, which gives me a multiplier of 1.05. So remember, when you do a percent to a decimal, you move the decimal point over 2 spots. Okay, the equation is y equals ab to the x. A is the start, which is 36,100. B is the multiplier, and x is x. Okay, you guys can do this part on your own. So I'm just going to take the start of 36,100 and multiply by 1.05. And I'm going to fill out my table down to the 8th year. And I'm going to round to the hundredths place because these decimals are getting long and I'm just too lazy. If you want the real truth. Okay. 36. So just like eyeball these as best you can. It's really hard to graph in the 10,000s, but we're just going to do our best. This is supposed to make a curved shape, but I guess we can't see it very well. But you guys all know it's supposed to be a curve, right? The reason it's not a curve on this is just because we're graphing within the 5,000s. Like, it's like, you just can't. If it was like zoomed in, it would be, but. Okay. A rubber bouncy ball is dropped from a height of 118 inches onto a hard flat floor. After each bounce, the ball returns to a height that is 20% less. Okay, so I need to underline stuff. This 20% less than the previous maximum height. What is the maximum height reached after the ninth bounce? Okay, so I'm going to go 100% minus 20% because it says less than 80%, which is a multiplier of 0.80. Y equals 118 times 0.80 to the x. Ninth bounce, geez. Okay. 118 times 0.8. Maybe we'll get a better curve shape out of this one. Ooh, yeah, this one's way better. Come on, honey. What? You want me to? This one's like, it's supposed to be curved and it's unsatisfying. Okay, what if I did this? That's kind of cheating. It's cheating. I cheated. You see my cheat? It gives you the illusion of being curved. It's supposed to be curved though. It's just because it's in the 10,000s, I promise. Okay. Anything you want to say about either of these two warm-ups other than about that? Like the process of getting the equation and stuff? All good? Anybody? Anyone gonna say anything? Hello? We're good? Okay. We are using a resource page today. If you could find the one that says foreign aid on it and just put that off to the side. No. Yes. Sorry. Foreign aid. Foreign aid. So this is the resource page. Just set it off to the side. Okay. Go ahead and set this up. I'm going to assign your digital escape. Don't let me forget to show you the joke and also the quiz topics. Uh, What? No, I keep most of it except for the stuff that's for the other book. I still haven't thrown any of that away. So that's kind of bad. But that's what I'm hoping to clean out. Okay, you guys ready? Not yet. You are ready. Okay. No? We're ready. We're not ready. We're ready now? Okay. All right. So, really important question. Is this a one variable inequality, a two variable inequality, or an absolute value inequality? Two variable inequality. How can you tell? Because it's got two different letters in it. The two different letters in it makes it two variable. Okay. So, step one, pretend you have equals. Y equals -5/3 x minus 3. Okay, come over here and graph it, but we have to decide if it's solid or dashed. Is this one solid or dashed? Solid. Does anyone need to know why it's solid? Are you good? Okay, so graph the -3 first, so down 3. And then the slope is -5/3. You're supposed to go down 5 over 3, but that's way off the graph. So I'm going to go up 5, back 3. Does anybody need me to count that off for them to show them what I did? So you're supposed to go down 5 over 3, but that's way off the graph. So I went up 5, back 3. You with me? No one's here today. It's just Mrs. Talbot alone, Michael Jew. This is Michael Jew. Solid or dash, Michael Jew. Solid or dash. Yeah, because it says the word solid up there. He's in stats. He's studying for the stats test tomorrow. Okay, anyway. Step 2. Test a point. What point is my favorite point to test? Yes. And can I test 0, 0 in this problem? Yes. And the reason is because it doesn't go through 0, 0. Okay, so I'm going to put that in the top. So 0 is greater than or equal to -5/3 times 0 minus 3. And now you can see specifically why I really like 0, 0. And that's because I don't have to sit here and figure out what 5/3 times z times anything is. Just 0. Okay, so I have 0 is greater than or equal to -3. Happy, Croc? Happy. True. Okay, that means 0, 0 is true. So that's above the line, and below the line is false. Okay, so you're going to find some kind of shading device, and you're going to shade the true side. Okay, any questions about number 52? So remember, the picture is the answer. There's not like a final answer type of inequality to write or anything. You guys okay? Okay. Now find that resource page in your packet, please, for 53. Okay. One of the purposes of the United Nations is to have nations work together to help each other. Recently, the members of the UN decided to give grants to poor countries to help reduce poverty. However, the United Nations only has the resources to help those countries in the greatest need. Therefore, it was decided that only countries in which the number of people in poverty is more than 1/2, I'm underlining the math stuff, of its total population would receive foreign aid. Write an inequality that represents the criteria to receive foreign aid. Let X represent the population and Y represent the number of people in poverty. Okay, so we're going to read this sentence. The number of people in poverty. What is that? Y is more than, greater than, 1/2. That's 1/2. Of is times its total population, X. So Y is greater than 1/2 X plus 0. Okay, do you need the plus 0 on there? Not really. Why did I put it? Yeah, exactly. So you could see that where the start was. The graph below shows the number of people in poverty per the population for each country of the countries being considered for foreign aid. Carefully graph your inequality from part A on the data graph below. Which countries should receive foreign aid? Okay, step 1, pretend you have equals. Y equals 1/2 X plus 0. Okay, however, this time it's dashed. Mrs. Talbot, good luck. You're going to have to remember that it's dashed. Yikes. Okay, so it starts at 0. So notice the origin is down here in this corner. And then it says the slope is 1/2. So up 1 over 2. Count it carefully all the way to the top. Don't forget to dash it. Okay, my next question is, can I test 0, 0 this time? I really want to. I like 0, 0. It's my favorite. Can I test it? No, it's not going to tell me anything because it's on the line itself. Okay, what other point should I choose? 0, 1? I like 0, 1. That's just lazy enough for me. Okay, so 0, 1, just so you know, would be right here. So that's the point I'm going to test to see if it's true or false. So I'm going to put it back into the original inequality, which is y is greater than 1/2 x plus 0. Okay, so I'm going to plug this stuff in. So y is 1. 1 is greater than 1/2 of 0 plus 0. 1 is greater than 0. True. So that means this side above the line is true and this side below the line is false. So get out your shading utensil of choice. Mine seems to have escaped. My desk, sometimes. Where did it go? Oh, here. I was gonna say, I didn't put it back in the box like an actual responsible person. No. Okay, last thing we need to do for this problem is list the countries that will receive foreign aid. Which countries are those? Rwanda. Actually, I think Rwanda's on the line when it's dashed, so I think that's not going to work. It has to be solid for that to work. So because it's dashed, that means it's open, and that one doesn't count. I think they actually just put Rwanda there for you to ask that question. Okay, I think there are 3 that work. Zambia, Madagascar, which is where Melman the giraffe lives. Do any of you know who Melman the giraffe is? From Madagascar? Yeah. The one that's like all afraid of diseases. He's like a hypochondriac and he wears Kleenex tissue boxes on his feet. And I love him. Yeah. All right. I think you guys are done with the package. So you can put that away because your digital escape is on the separate sheet I gave you because Miss Rice and I are champions. We're champions of packet making. Mr. Madaver found the mistake, by the way. I see you all accusing me of having a perfectionism complex. I do not resemble that remark. Yes, I do. I'm a Virgo. Explains everything. Okay, let's do this one. So this is really well timed because this is very similar to the resource page, not the resource page, the warm up we just did. So step one is pretend you have equals, and that would be y equals 3 times 0.8 to the x. What you're going to need to know is this is going to be a curve when you graph it. It's not really going to change the rest of the problem. It's just going to be a curve. And we also need to know that it's going to be dashed. Does that make sense to you guys? Okay, to graph it, I'm just going to make a couple of spots on a table. I'm not going to do a big table, but I'm going to do a couple spots on my table. So I know that it will start at 3. And then times 0.8 is 2.4. Times 0.8 is 1.92. Just going to graph these couple of points to help me get the sketch of the curve. So 0, 3, 1, 2.4, 2, 1.92. If you want to be more particular about that, you can definitely make a bigger table than I did. Okay, in this problem, is 0, 0 open to test? Yep. It's not on the curve at all. It's completely separate down here. So I'm going to test that. So 0 is greater than 3 times 0.8 to the 0. Okay, you can totally do this on the calculator, but let's not. What's 0.8 to the 0? What's anything to the 0? 1. Anything to the 0 power is 1. So 3 times 1 is 3. Unhappy clock, right? So that means that the other side of the curve is my true section. So what's the difference between this and the linear ones? You really just have to make a little table so you get your dots. last thing in the notebook here. And 55 has a couple of special cases in it. This is kind of a reminder from chapter 2 of how to graph y equals and x equals stuff. So we're going to start with 55a. Step 1 is to pretend you have equals y equals -3. What type of a line is y equals -3? I love all of your very adorable answers. What I'm looking for is it's horizontal. You're not wrong. Okay. Also, it's going to be solid. Do you see where the solid came from? Okay. So we graphed these in, I'm gonna get a different color here. We graphed these in chapter 2, and we graphed them a little bit after, but it's been quite some time. So I went down 3. Okay, and then I'm going to test a point just like I would with the other ones. But it's going to feel weird to you. I'm going to test 0, 0, which is right here. It's okay to do because it's not on the green line. But you're only actually going to plug in one of the zeros. You're just going to put it in the y spot. So 0 is greater than or equal to -3. Yes, which is true. Okay, so that means this is true. This is false. And so you're going to shade toward the true. So what's really different about these really is just that they're just horizontal and vertical. Well, I think I just spoiler alerted B. Okay, so B. Step 1, pretend you have equals x equals 2. X equals 2 is a vertical line, and it's going to be dashed. Okay, so the vertical part comes from chapter 2, but the dashed part comes from chapter 9. Okay, now I'm going to test the origin again. It's going to feel weird though, because you're only going to plug in the x is 0. All right, those are done. Okay, last one, number 56. Number 56 is a backwards type problem. Number 56 wants you to take the graph and figure out the equation. Oh man, it's not really that bad. Okay. So the first thing I want to identify is what is B? What's the y-intercept of this line right here? -1. Beautiful. Okay. The next thing I want to identify is what is the slope. So I'm going to go like deep, 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 like this. That was terrible. I'm going to go like this. Okay, so what is the slope here? Yes, -1/3. Does it make sense that it's -1/3 because it's going downhill? Okay, next question. Is it solid or dashed? Dashed. And is the shading less than or greater than? Just in your gut, does it tell you the shading's less than or greater than? So below or above? Below, so less than. Okay, so we're going to write this in an inequality. Y is less than. We're going to leave it regular less than because it's dashed, so we don't want to put the or equal to on there. -1/3 x minus 1. Okay, that part is done. We're not done though. Please read this. I'll do that after this. I'll do the good news or the fun thing after the painful thing. Sorry, Michael. I will, I promise. I just want to do this first because I have the long mental checklist in my head. Okay. Got a quiz. It's tomorrow. It's on tomorrow. I know. It might be sneaking up on you. You have a quiz. Tuesday, May 7th. That is on tomorrow. Okay. Let's talk about what these things are. Solving and graphing one variable inequalities and absolute value inequalities. Those are the ones that are on the number line. One variable inequalities is you pretend you have equals, you put the dot on the number line, and you test something to see if the arrow goes right or left. Absolute value inequalities. Those are you pretend you have equals, you split it into two pieces to get the positive and negative, remember? You might have to look back at that, like, so you have like x minus 3 equals 5, x minus 3 equals -5, and then you like have two dots on the number line, you test something between and it's Baymax or arrows out. You had a digital escape on that. You might need to look at that overnight. Graphing two variable inequalities, that's what we did today. It will be a line, don't worry, it's not going to be a curve. Graph a line, dashed or solid, test the point, shape. And then writing an exponential equation from 2 points, that's where you make the table, you count the b's, you're at like 8b cubed equals something, solve for b. Luckily, one of our warm-ups tomorrow is that, because that was back from chapter 8. But the second warm-up we do tomorrow will be that. So we'll review that tomorrow, but you guys should look at the one variable and absolute value inequalities overnight. If you're on the digital escape for the absolute value inequalities, I can help you with that now if you're stuck. Okay, last thing is the joke. I think I like it. It's pretty good, especially with my keto diet. Okay, so this is what we did. We already did it. It's done. Homework is the graphing linear inequalities digital escape. It says Billy has 32 pieces of bacon. He eats 28. What does he have now? Happiness. Billy has happiness. Yeah, but he might have a stomach ache, but he's got happiness. I was watching the spring baking championship, and this guy got in trouble because he put too big of a piece of bacon on the top of a like muffin. Like, how? What? How? What?
No bacon for me.
I know. Now there was another dude who didn't cook his enough. That was understandable, but like, too big of a piece? What is that?